Well, hey everybody, welcome back to Master the NEC, sponsored by the Electricians Academy, and we're now moving into part 1, or Article 100 of NFPA 70E. We're going to talk a little bit about definitions today. Now, hopefully you've watched our Article 90 episode and got the basic gist of what's covered and what's not covered by NFPA 70E, which is the basically your safety guide for safe work in the workplace, or working with electricity in the workplace. It's all about safety. And this document is pretty small, but is very impactful. And it's something that I probably think that most electricians don't own, which is what's spawned me to kind of do this series. And since I know that most electricians will not own it, I will talk about it at a very high level so that you can just pull out the parts of it that are most important. Now, we're not saying this is for the electrical safety engineer or for somebody that is heavily involved in electrical safety aspects of NFPA 70E. Not what this is for. This is a series that's approaching the electrician who probably, for one, owns this document, which is the National Electrical Code, which is NFPA 70, but they probably have absolutely zero knowledge of NFPA 70E, other than what's probably done on the job site during work safety meetings and things like that. So this is an electrician's working man approach to looking at 70E. And so that's what we want to do in this episode. Okay, so now let's go on and get started and look at definitions. Now we can go all the way back here to the very beginning, and we can look at these definitions, and we're only going to cover the definitions that we feel are relevant to us having something to do with electrical safety. And those that aren't covered already in NFPA 70, the document for NEC, only things that are covered here in NFPA 70E, which is, again, standard for electrical safety in the workplace. And we're going to be working, again, out of the 2021 edition of the NFPA 70E document. Now, a couple of things that we want to understand is, again, Article 100, just like it is when you're dealing with the NEC, is if a definition is used in 2 or more articles, then it actually is going to make its way over into Article 100. So that is very similar to what we'd see in the National Electrical Code. But this is 70E, so this is dealing with safety. And so you watched our first episode, which is 90, Article 90, you understand what's covered and what's not covered by this document. So moving forward, we're going to assume that you're looking at 70E because you're working in a location that is required to be covered by 70E, okay, for the safety. And you're an employer maybe who's got to make sure that you provide PPE, a lockout tagout procedure, a safe working order. Hopefully you have energized work order plans that, if it's necessary, that you have it in place and you're willing to sign it. We'll talk about that later. And all those conditions that would come up that can affect electrical safety. Okay, so let's look at these definitions because I believe it's critical. Now, we're not going to be redundant here. We're not going to cover the definitions that are simultaneously covered over in the NFPA 70, which is the NEC. We're only going to look at those that are very unique to 70E, or maybe there'll be some overlap because, again, the germane text needs to be discussed. But other than that, we're going to stick to things that are unique to 70E. And the first one we're going to look at is arc flash hazard. What is an arc flash hazard? Now, remember, we're going to talk to electricians here. I am not doing this series for electrical engineers who are safety experts or people that do this every day for a living, engineers that are very focused on 70E. That is not what we're doing today. This is strictly for the electrician who probably doesn't own a 70E, who doesn't have the understanding or the knowledge of 70E. They're used to working with this book on a daily basis, but yet the hazard they encounter can be life-changing. Now, I hear people all the time say, well, I got electrocuted the other day. Trust me, if you got electrocuted, you're dead, okay? Now, you might have gotten shocked, and if you did, then you might have done so carelessly, all right? So the difference with 70E is that we want to try to put everything into a safe work condition, or tell you how to make something a safe work condition. And if you have to work on something that is energized, that you do so safely under the guidance of this document. Now, there are other ways to do this. You could have an engineer do this, and they could do all the studies, and they could do the available fault currents and all the incident energy and come up with their own formulas for flash boundaries, limited access, limited approach, and they could come up with their own rules. They could tell you what types of suits you have to wear or what you don't need. They can do that. But if you're the electrician like me, the easiest thing to do is grab an NFPA 70E document and follow it at the minimum. Because if you follow 70E, you're going to be safe. Okay? It's kind of like the NEC. If you follow the National Electrical Code, you have the most minimally safe installation that you can get. Okay? And so that's why it's a minimum safety standard. Well, this safety standard is kind of the same thing. If you follow this, then you're going to be in the safest condition in the workplace that you can be in. If an engineer or somebody else wants to go outside the parameters of 70E, then they're the ones that are responsible for that, and they have to make sure they're following everything to the letter, that they do all their calculations right in order to do that. Here, I like to err on the side of conservative and cautious, and that's why I believe in 70E. Okay? So I wanted to lay that long, rambling sentence out there. Again, a very inexpensive document, great to have. Hope everybody in the electrical workplace gets one and has it handy. All right, now, definitions. First one, arc flash hazard. And again, we're going to just read the definitions. We're not going to get too deep because we're going to use them later when we look at other articles inside of 70E, and so that you can kind of relate to what it's kind of saying. All right, arc flash hazard, it is a source of possible injury or damage to health associated with the release of energy caused by an electric arc. So that creates an arc flash hazard. A hazard to you and a hazard to me. Okay? Possible injury or damage to my health associated with the release of energy. Maybe it's an arc flash blast or whatnot due to an electric arc that could cause injury to me or even death, which I would argue is injury. But it could be something, for example, where you get complacent in this industry. And what if you were in an arc blast and you weren't taking these things in 70E into consideration, and you ended up burning your hands to where you no longer can hold anything, and you have a young child and you no longer can hold that child? This document is trying to set the tone here and say, look, there are conditions that can be extremely unsafe, and you have to prepare for that. That's what this document is trying to do. Okay, so it needs to be really embraced to understand it. And again, I know many electricians, if I ask them, do you own a copy of 70E? And they say, I do not. Okay, all right. So if you're an employer, you need to make sure you have one and that you do training, because I can tell you, somebody gets hurt and you don't have PPE provided for your employees, or you didn't do training, be prepared, okay? Because they love you now, but they might not love you once they get their ears blown out or third-degree burns or whatnot, and they got family members and now they can't feed their family, or worse, they are bedridden. Just watch out, because you know what? The lawyers will come a-calling, okay? All right, so that's an arc flash hazard. To go in, there's informational notes, as you heard in when I discussed Article 90. Great information there. We're not going to go into details, but again, great information. The next thing is an arc flash suit. You've probably seen the pictures where people get into this suit and it has a backle of a hood, and you have this suit and it's got this certain calorie rating per centimeter square, and it allows you to approach certain types of tasks on electrical equipment. And those tasks give examples in Table 130.5C. But then you have this suit, and it's what is called arc-rated suit. And it's a complete arc-rated clothing and equipment system that covers the entire body, except for the hands and the feet. So the hands will have gloves, and the feet will have boots that you'll wear. But other than that, it's basically an arc flash suit, and it's rated, arc-rated, usually in calometers per centimeter square. You've seen them. We've seen them in 10 calories, 40 calories, and up. They're just all over the place with it, depending on the amount of energy you're going to be coming involved with, the level of the arc flash hazard that's involved. Okay? And again, we'll get into all that when we get into the different approach boundaries that we have to take into consideration. Next is arc rating. So a lot of equipment and a lot of different suits and a lot of different things will have an ARC rating on it. So we got to make sure that we at least cover the ARC rating statement. And what is it? It says the value that's attributed to materials that describes their performance to exposure to an electrical arc discharge. Okay, you have bolted fault, you have this discharge, and you have an ARC rating that gets attributed, and it can be based on an ATPV, which is the arc thermal performance value, or it can be based on what's called the EST, which is, again, that one is ARC rating, and that is called the energy of break open threshold. Now look, you saw me reading that. It's the same thing you can read out of the 70E. I'm an electrician. And so there are people that do nothing but are experts on this, and they do a lot of training on this. And they do their best to try to teach you how to come up with ATPVs and how they come up with them, or the ESTs. Look, I'm an electrician. I'm going to follow 70E. All I want to know is something ARC rated? And am I going to be able to use this in an application? And so what I'm looking for is an ATPV as an ARC rating or an EST. And again, it could be either or. Whichever is the lower value is acceptable for the condition based on the task at hand. But I need to know the ARC rating of the material, whether it's a suit, whether it's the clothing. Now, again, also remember that things will come in what's called flame retardant clothing rating, and they're not the same, okay? That's when we're going to bring in informational note number 1, because informational note number 1 is, again, not enforceable, but this is an example of an important statement, especially when people see something that has an ARC rated clothing and things like that, but yet they have different things that maybe are not ARC rated, but are flame resistant type clothing or have a flame rating. So let's kind of look at this. Informational note number 1. It says, ARC rated clothing or equipment indicates that it has been tested for exposure to an electric arc. Okay? So obviously ARC rated, arc exposure. It's been rated to a certain level. Flame resistant clothing without an ARC rating has not been tested for exposure to an electric arc. It has only been exposed to flame-resistant ratings, okay? Now, notice that last sentence. It says, all ARC-rated clothing is also flame-retardant. But not all flame-retardant is ARC-rated. Important when you're making that selection. Obviously, we'll have some tables in 130 and things like that we're going to look at as we work through this 70E. And you got to remember that they don't equate. If it's ARC rated, you'll get the flame rated properties to it. But if it's just a flame retardant clothing and there's a need for an ARC rating, it is not evaluated for an ARC rated situation. So again, that's important of understanding the difference. And that's the reason I wanted to talk about informational note number 1. Now, note number 2 and number 3 just goes into backgrounds of the standard that developed for the ATPV or the EST. If you want to do that additional research, those ASTM documents are available. Check them out. I'm not going to do that. As an electrician, I just want to know what this document's telling me. And when it makes a reference to ARC rating, I now know what that means. It was based on ATPV or EST, and that's how it got its ARC rating. And I also took away an important gem, is that flame retardant clothing isn't necessarily ARC rated, but ARC rated clothing is flame retardant. It's a lot. That's a lot to take in, but there you go. All right. So let's kind of go through this. Here's another term that's probably unique here that you're not going to see in the NEC is the baklava, which is an ARC-rated head protective fabric that protects the neck and head except for small portions of the facial area, okay? Which most of the time will probably have a shield or whatnot on it anyway. But again, it's kind of the hood you put over it. And so again, it's called a baklava. I'm probably saying that wrong, but that's the way I'm saying it. And it is ARC rated, so obviously it's flame rated too, based on what we just read. And so again, there's a new definition, or not new, but something you might not see, obviously, in the NEC, because it's very much germane here. Now, the other terms you see are very much covered, like bonding and all that kind of stuff. Oh, this is a good time to show you what I was talking about, brackets. So this is an example right here of the bracket. that's just letting you know that the definition comes from NFPA 70, Article 100. So if you ever wondered where it comes from. Now, that does not mean that you have to go to 70 and follow what it says in 100 for bonding. It just means that it's derived from that other NFPA standard. And it's just telling you that as informational purposes inside of the brackets. Okay, it's kind of figured as a good time to talk about that. Oops, sorry about that. Killed my screen on you. All right, so let's go to the next one. Okay, the next one we're going to talk about is arc flash boundary. Now, when you have the source of a potential flash, okay, let's say it's the source of the energy, say at a terminal or a piece of equipment where the energy is inside of equipment or electrical conductors, that at that point it emanates out. The hazard can emanate out, okay? So you create different boundaries, and they'll be called like limited approach boundaries, restricted approach boundaries, arc flash boundary. So you've got all these different boundaries, but have no fear. As we work further on into our 70E analysis, we're going to discuss these different boundaries and give you examples of it. So I'm just going to read definitions right now so that as we use them later, you can relate, and then we'll kind of examine that and translate what they're trying to say. So let's kind of focus on definitions again. So arc flash boundary, what is it? It says when an arc hazard exists, an approach limit from the arc source at which incident energy equals 1.2 calories per centimeter squared. Okay, so there's a value. So from the source out, there is a boundary, okay, that energy approaches 1.2 calories per centimeter squared. And so that defines it right there. And that defines that arc flash boundary, okay? And so again, when we look through the code, and a good thing to look at is the informational note here, because as you see, we're going to have some figures that are in the NEC that kind of give us this example. They're called figures, and they'll give us example of the different boundaries and how they relate so that we can use them later in the code when something in the standard says do not go beyond the limited approach boundary or restricted approach boundary and this and that. You kind of know what it's talking about, right? So what is the informational note? What does it bring to the table? It says, and we're right here, and it says, according to the Stahl skin burn injury model, it says the onset of a second-degree burn or unprotected skin is likely to occur, okay, so we're talking second-degree burns here, of skin that's exposed, unprotected, is likely to occur at an exposure of 1.2 calories per centimeter squared for 1 second. Okay, so at 1 second exposure, at the point where it's 1.2 calories per centimeter square, you're going to get second-degree burns, okay, which is very painful and can be devastating. You get any closer, obviously that's going to elevate it up. You get third-degree burns, okay, catastrophic. But even at the boundary, flash boundary, that's going to create at 1.2 calometers per centimeter square, you can create second-degree burns on unprotected skin. So you have this boundary that you need to stay out of, okay? So, and why is this important? Because I could be working on a piece of equipment, and I could have my suit on, but somebody else could come into my work area unaware. And we have to understand that there is a boundary that flash could affect somebody's open skin that is not aware of what you're doing. So that's why it's so important to guard off your area, follow procedures, and at the end of the day, de-energize when you can. And most times you can always de-energize, but there are going to be situations where you're working in components where there is energized parts. Maybe they're guarded or enclosed away from where you're working, but the hazard is still there. And so you have to understand that. And we're going to look at all those examples of that as we go through this series. Just be careful. We know that blast, that arc flash boundary that can create that energy from the source out, that hazard can create a lot of problems. And we want to just be careful with that. The next one we'll look at is the limited approach boundary. Okay, so what is this? It is the approach limit at a distance from the exposed energized electrical conductors or circuit part within which a shock hazard exists. So you have the conductors that are energized. Obviously, they're energized in the equipment, but they're energized. They might go to a terminal. Well, then you have a lot of bus bars or parts. All of this, there is an approach limit or a distance that you can get to that we call the limited approach boundary, that point where you can't go past, okay? Whereas increased likelihood, okay, of something could happen. Now, the approach limit is a distance from the exposed energized electrical conductors or circuit parts like bus bars within which electric shock exists. It exists. It's going to happen, okay? So you don't go past that limited approach boundary, okay? Now, let's look at what's called a restricted approach boundary. And again, later on, we'll see how they overlap each other, kind of this sphere, if you will, around where the source is. Now, what is a restricted approach boundary? And you're going to see it as we look at it later. It's an approach limit at a distance from an exposed, energized electrical conductor or circuit part within which there is an increased likelihood of electrical shock due to electrical arc over combined with inadvertent movement. Okay? So, in other words, if I'm in this restricted approach boundary, and I could have, let's say, an arc over happen, and I could have other movements that could, inadvertent movements due to some type of incident, blast, or what have you, that could cause me to touch or come in contact and get electric shock from it, okay? So I'm in something, okay? That's going to be a restricted approach boundary. And again, we're going to show you how that overlays, just kind of giving you the 30,000-foot view of definitions. Otherwise, these videos would be, or this podcast would be forever. So again, that is what's called a restricted approach boundary. And again, we'll bring it up as we approach it, as we examine 70E. Going down other parts of it that are unique here, de-energized. Okay? Now, while it's not unique in this concept of what de-energized means, is turn something off, it's important when it comes to 70E because the ultimate safest work condition is when you de-energize something. And of course, obviously we'll talk about it later, lockout, tag-out procedures. I'll give my recommendations and things on that. Putting in a safe condition where somebody can't turn it on, de-energizing it allows me to work on something freely. I can take off any gear I have. I don't have to be restricted when I'm working on it. Why? It's de-energized. So it says, free from any electrical connection to the source of potential difference and from electrical charge, not having a potential difference from that of the earth. Okay. Now, currents transfers and shock comes from difference of potentials. Okay. I'm at a different potential. I touch something else, creates a potential, and then that's where you get shocked. Okay. If it's all de-energized, there's no risk involved. It's de-energized. Okay. So that's the safest condition to be in. And if you can do that, that's where you should be. In fact, for electricians out there who work on even just the simplest in houses, there's no need to work on a circuit energized. And you want to be like a He-Man, that's fine. I have people that send me pictures of people cutting circuits with their Kleins or side cutters because they can't find the breaker. Okay, look. Unless grandma or grandpa or a mother-in-law, well, mother-in-law will be all right, is up on a ventilator, then cut it all off or identify the circuit. Take a little extra time, but then if it's not labeled properly, maybe you should help them out by labeling it. Maybe that's a charge you can charge for a service. Like, look, we need to label this panel properly. It's not labeled right. So whatever, take that opportunity because somebody could get hurt. You could be dealing with it and think it's just a simple shock. It's a 120 thinking you won't get hurt, which you can. Okay, it only takes 1/10 of an amp to kill you. But you're up on a ladder, something happens, it startles you, and you fall off the ladder and you get killed. You break your neck. It's just not worth it. Again, I'm not soapboxing it. I'm just telling you, why do we have to be a He-Man? If that's how you want to be, that's up to you, okay? That's up to you. But don't expect sympathy or pity when something happens to you because you didn't follow rules, safety rules, because you're not going to get it from me, okay? All right, so maybe you don't want it from me, so that's okay. All right. So anyway, so de-energized, again, de-energize it. Again, we'll talk about lockout, tag out later. Electrical hazard. What's an electrical hazard? It's a dangerous condition such that contact or equipment failure can result in electric shock, arc flash burn, thermal burn, or arc blast injuries. Okay? So, electric hazards, right? Anytime we're working with electricity, we run the risk of working with hazards. Okay? So that's something that we've become used to. Right? And we wear our gloves, we wear our protective eyewear, we understand what we're working with. Again, we all want to get home to our families. Again, we don't have to be Superman. Now, if you want to be that backwoods, if you've watched my series called Electrical Blunders, which again is over on our YouTube channel, hopefully you check it out. It's a new series in 2021 that shows all this stuff that's either misleading or wrong or stuff you shouldn't do. Go check that out. It's a neat series over on our YouTube channel, Master the NEC. Just search for it over on our YouTube. Other than that, electrical hazards are dangerous and they exist all over the place. Okay, now, informational note, important here. It says, Class 2 power supplies, listed low voltage lighting systems, and similar sources are examples of circuits or systems that are not considered an electrical hazard. Way important because people ask me all the time. Class 2 power supplies, again, are very limited. Listed low voltage lighting systems are very limited in their power that they can produce, so the hazards are very low. But those are examples. Okay? Now, you have some examples where you'll have broadband powered networking systems that do have levels of voltage that are hazardous. So, again, this is just giving you an informational note. This is obviously not all the conditions, but this is just telling you some systems that are examples of circuits or systems that are considered not really electrical hazard. A great example of this would be a doorbell circuit, okay? Secondary side of a doorbell transformer, 24 volts, 18 volts, 12 volts, whatever it may be, whatever your flavor. That is not an electrical hazard. Okay? Now, with that said, could you still get a light shock from it if you're on a ladder and it startle somebody? Maybe. But again, not as far as NFPA 70E is concerned, is it an electrical hazard. Okay? Now, one of the ones that I really like is this one here in the middle of the screen. It's electrically safe work condition. What is that? You're going to see that we talk about 70E says putting things in an electrically safe work condition. What does that mean? Okay, well, let's look at it. It says a state in which an electrical conductor or circuit part has been disconnected from energized parts. Hey, remember what we just talked about? That's a safe working condition. That's always going to be the safe condition. What else? Locked and tagged in accordance with established standards. That means you've established a lockout tagout procedure. If you're the owner and you have people that work for you, you should have a process to follow. You should have a lockout tagout procedure and you should stick to it. Make it habitual that you follow it in all cases. Okay, so it says that. Tested to verify the absence of voltage. Remember the old saying, test it. If it's dead, test that on a live circuit to make sure the meter's working. Then test the de-energized or locked out and tagged out circuit. Make sure it's dead before it. So again, tested and verified. Don't be afraid to do it twice, okay? And if necessary, temporarily grounded for personnel protection. Again, depending on the size and what you're dealing with, some of the protocols might mean to also ground the system, and you need to do that. If necessary, if it calls for it, then do so. We want to put it in an electrically safe work condition. And again, ultimately de-energizing it is the safest work condition you can have. Now, informational note. It says, an electrically safe work condition is not a procedure. It is a state wherein all hazardous electrical conductors or circuit parts to which a worker might be exposed are maintained in a de-energized state for the purpose of temporarily eliminating electrical hazards for the period of time for which this state is maintained. Okay, so if I'm going to work on something, I de-energize it or I lockout tag out to effectively de-energize the circuit or the circuit parts that I'm working on for that state that I'm working on for that period of time. Once it's completed, everything is done, then I follow my procedures to remove my lockout tagout situation or re-energize the circuit following a procedure that you establish in your company. And I hope that every company has a procedure. Even if you're working in residential and you own a company and you have a bunch of guys, establish a procedure that they're supposed to do before they work on circuits. That protects you as the employer. In other words, if Johnny's going to go out to put in a ceiling fan, make sure they understand that they will de-energize the circuit. That's the first step before they go and do anything. In fact, what I used to do is I would de-energize it and I would put tape over it so that it's marked. And I had orange tape, and I would put that over the breakers so that nobody could inadvertently turn it on. Now, of course, somebody could remove the tape, but even in a residential, that's an extra step to kind of tell somebody, do not. And a lot of people, what they'll also do is shut the cover door, and they'll put a piece of duct tape over the actual cover and write on it, keep closed. It can't, because you can always rip the tape off when you're done. However you want to do it, that might seem like overkill, but again, if I expect my employees to follow a procedure, then I don't have to worry about them getting shocked. I don't have to worry about them trying to be a cowboy or some kind of impress somebody. I don't have to worry about it because this procedure is... Now, if they deviate from the procedure, it goes to court. I can say, look, we have a standard procedure. This procedure wasn't followed, okay? And they signed it, okay? Again, protecting yourself as an employer is important as well. We care about our employees, but we have to protect ourselves. We're in business, okay? Just things to think about. Always kind of think of those things. Here is another term, arc-resistant equipment. So again, it says, oops, sorry about that. I keep turning it off. It says, equipment designed to withstand the effects of an internal arcing fault and that directs the internally released energy away from the employee. Okay, so it could be arc-resistant equipment. It has blast channels, if you will, vents, and in the event something happens, it will take the blast and direct that energy away from the employee that's working on it. So you might have equipment that is arc-resistant equipment, okay? So different things. And again, you have some informational notes that really give you some other information to be aware of, but that's what arc-resistant equipment is, okay? And again, let's see here. Nothing else that really isn't any different than what we saw in the National Electrical Code, so I won't rehash those. I will tell you, the available fault current, the little diagram here, was introduced in the 2020 NEC. And again, I think it was a great move. And here it is again here. You see it talking about the source. You have the available fault current, and you have the available fault current here again at the line side of an overcurrent protected device. You have available fault current downstream at the actual load. All of this creates incidental energy. All of this can create arc blasts. Again, it's proportional to how far it goes in. More resistance to the conductors. Length is your friend. But again, there's all this energy, and so available fault current has to be taken into consideration when engineers design it, when they're doing these risk assessments and everything else. Okay, so again, nice little diagram. Nothing new that you wouldn't see in NFPA 70E. Again, I'm just looking for changes that we want to be aware of. Obviously, hazard, a source of possible injury or damage to the health. Hazardous, involving exposure to at least one hazard. If it's at least one hazard, then it's hazardous. Okay. Incident energy. You've heard me use that term, incident energy, right there. Okay, I can't highlight it all, but there you go. Incident energy. What is it? All right, so incident energy is the amount of thermal energy impressed on a surface a certain distance from the source, generated during an electrical arc event. Incident energy is typically expressed in calories per square centimeter. So that's where we got the calometers per centimeter square or calories per square centimeter. Either way, this is the amount of energy, and this is what suits are rated for when they get a cal rating. They're being rated for this incident energy, this this energy that it emanates out from the source of where that energy starts, okay? And so, again, let's just use an example of a bolted fault that creates this energy, and it creates this incident energy that comes out, okay? And so the suits and the equipment that can be rated for its exposure in that potential effect comes in what's called the calorie rating, okay? And it's calories per centimeter squared. Next one would be incident energy analysis. And these terms will be used over and over again in 70E. That's why we're going over them. So this one here, incident energy analysis. This is a component of an arc flash risk assessment used to predict the incident energy of an arc flash for a specific set of conditions. So there'll be a situation in here where we'll talk about incident energy analysis based on a arc flash risk assessment. And of course, you have examples of that in the informative annexes to look at as well. But throughout the different articles in the 70E, it's going to make a reference to incident energy analysis as a result of a arc flash risk assessment. Okay, so you'll get that. Now, it's going to ultimately tell you that there's a certain level of incident energy, and it's going to tell you a certain type of calories per square centimeter protection, PPE, that you need, okay? So I'm sure we're going to see that definition, PPE, also a little bit later, okay? So anyway, just kind of definitions that we need to take into consideration. Another one is condition of maintenance. Now, what is that? So you see this referenced in 70E. What does it mean? It is the state of the electrical equipment considering the manufacturer's instructions, manufacturer's recommendations, and applicable industry codes, standards, and recommended practices. It's going to tell you when something needs to be maintained, how often it should be checked, all those type of things. Manufacturers give instructions for everything, okay? How often something should be tested, all this type of stuff. So, condition of maintenance, all those things. So when you see that, it'll be in context to what it's stating inside of the code material. But again, just a definition that might be new to you that you haven't seen in other locations. Now, this is important. Even though it's covered in the NEC, I feel it's imperative that I cover it here. Qualified person. Now, this term gets thrown around a lot. I mean, we're electricians. We work with electricity day in and day out, some of us more than others these days. But at the end of the day, there's a lot of things in the code that says you have to be the qualified person. And what is a qualified person? For example, if you're an electrician and you've never done a PV system in your life, you're not the qualified person to work on a PV system, even though you're a licensed electrician. You're not qualified. If you've never done a wind generation, you're not a qualified person. Okay? So it's all relative to your experience. Okay? Now, this is why it's important, because when we talk about qualified person in the NEC, NFPA 70, that you and me are used to working with out of this document, it makes a statement that you're aware of electrical safety and the hazards involved, and you know how to identify them. Okay, that's going to take training. And that's where a 70E comes in. So how many electricians out there have actually had formal 70E training? Now, that's what this video series is going to cover. We're going to talk about it as it pertains to 70E, not as what an engineer might do or somebody that specializes in it, where they can do all the calculations and things like that. We're not getting into that because we're electricians. We want to be able to pull up a document and use it. And that's what the 70E is about. Simple document design for safety. That's what it is. We're not going to get into complicated calculations that are done by engineers. You can do that if you want, but then when something happens, they're going to call into question whether or not you were actually qualified to even do those calculations. You can follow 70E and be safe, okay? But let's talk about qualified persons. This is what it says. It says, one, you or me, who has demonstrated skills and knowledge related to the construction and operation of electrical equipment and installations. And, okay, so that covers our install. That covers our training, how to put stuff in. But it says, and has received safety training to identify the hazards and reduce the associated risk. What does that mean? I can identify a hazard, I can identify a risk condition, and I can also identify how to mitigate that risk or how to reduce the risk by lockout, tagout, by proper PPE, by all of these conditions. I'm reducing the associated risk. And in many cases, eliminating the risk, okay, by using de-energized practices. The point is, are you qualified? If you've never worked on a switchgear, but you're an electrician, are you qualified? Well, you would be if you worked on a job site and you worked under the tutelage of a master who's done this and you're helping out. You're getting that skill, that training. But to simply throw an electrician into that, they're not necessarily a qualified person. Now, do a little research, do a little training, do a little, ahead of time work, then you can be a qualified person. But you got to put the time in, you got to put the work in, you have to put the training in. Other than that, you just can't start doing things that you have no experience in and all of a sudden be considered qualified person. Just because you hold that license that says you can do it, it doesn't necessarily make you qualified. And if you haven't done any 70E training or you haven't done any safety training at all, are you really qualified? Not by this standard. And it goes to court, we're going to eat you up. Electrical expert's going to go in and say this person wasn't qualified. I want to see their safety records. So as an employer, make training a priority, keep documentation, make everybody sign that they attended the safety training. Document, keep it away in a filing cabinet, have it there for your protection. I'm just saying, that's what I would do. Okay? Anyway, that's my rant on qualified persons. Next, we're looking at, next is risk, and then we'll look at risk assessment. Okay? Now, what is risk? When an electrician or electrical worker works on something, there is something called risk. What is it? It's a combination of the likelihood of occurrences of injury or damage to health and the severity of injury or damage to health that result from a hazard. So risk is broken down to different levels, okay? There's different risk levels depending on the exposure or the risk to your health or basically to your life. And so everything's placed in a certain type of risk. Now, that drives us to what we call a risk assessment of the risk. And here's what a risk assessment is. It is an overall process that indicates, that identifies hazards as they are, eliminates the likelihood of occurrences of injury or damage to health by doing a risk assessment, estimates the potential severity of injury or damage to health, and determines if protective measures are required. So it kind of looks at the risk. It assesses it and says, well, this is a low risk. This is a higher risk. This is a serious risk. And it kind of puts them in different categories. Okay? So that's why we now want to look at an informational note, because it says this. Under the informational note under risk assessment, it says, as used in this standard, okay, we're talking risk assessment, arc flash risk assessment and shock risk assessment are types of risk assessments where you're trying to analyze what is the arc flash risk and what is the shock risk. And that's how we create the different PPEs. That's how we did the different boundaries. And we all establish it based on the risk to you and me for working on electrical equipment. Okay? So, critically important to understand risk, and then, of course, how that risk is assessed so that we can use the different layers to determine approach boundaries and all these type of things and PPE and all that kind of stuff. Okay? Shock hazards. Okay. Because you heard that term used in a definition. It says, a source of possible injury or damage to health associated with current through the body caused by contact or approach to expose energized electrical conductors or circuit parts. Again, look, it could be in contact or it could be due to an arc because of differences of potential that the closer you get to it, you could have it arc over to you. Okay, so shock hazard is so important because it can result in catastrophic effect of death or something that affects your health long term. Blinding, crippling, paralyzing, loss of use of hands, all these type of things. Again, this is an example under the informational note that I love because it gives us something that we can really sink our teeth into, and that is, read the informational note. It says, injury and damage to health resulting from shock is dependent on the magnitude of the electrical current, okay? The power source frequency, whether it's 60 hertz, 50 hertz, or what have you, and the path and time duration of current through the body. So the level of current, okay, the number of amps, the current, the frequency, whether it's 50 hertz, 60 hertz, in most of our cases it'd be 60 hertz, okay, which is very much the same frequency that we have signals to the brain, okay, so that case 60. The path, whether it's through arm to arm, through our heart, or from arm to foot, and it has a path. However the path takes can be a huge factor on the damage that it does and the duration or exposure to that current through the body. All of those things can have the shock hazard in different magnitude effects. Okay. Now, it goes on to say the physiological reaction range from perception, muscular contractions, inability to let go, ventricular fibrillation, where the heart goes into a flutter and it can't pump oxygen or blood, to tissue burn, whereas it burns it so severely due to that shock, and ultimately it could be death. When you hear people say they got electrocuted, no, they got shocked. Depending on the severity of that shock, they became a shock hazard. That was a injury or damage. Now, it might be mild, but it could result in a reaction that causes something a lot worse, or it could be so severe that it literally burns the skin, or you come in contact with it that you can't let go. Okay, that let go threshold that we'll probably talk about later. All those type of things, ultimately, the more you perspire, then the contact surface resistance goes down. Again, we're made up of a lot of salt, okay, conductive. So if you think about it, the resistance will go down and death would be imminent. Okay, but you could also have severe tissue burns that affect you for the rest of your life. So these are things that we have to think about. So you're going to see references to shock hazard, and kind of now you have a concept of what we're talking about. Okay, and all the other stuff so far is, pretty much the same as what we covered before. So I don't have to go into too much additional detail. Another stuff just is pretty generic, so no need to go into any of that. Now, I noticed that I didn't see, maybe I missed it. Okay, there is no definition in here of PPE. So we'll talk about PPE a little bit. So personal protective equipment is things like the gloves, and it'll be referenced in the actual standards. It'll be like the gloves or your suits that we talked about, or things like that that's going to protect you from exposure to the live parts or to arc blasts or incident energies and things like that. You're going to have requirements for certain PPE, protective equipment. And again, as we get further into this series, you're going to see requirements for certain calorie ratings for this PPE and things like that. So again, or certain voltage ratings when it comes to things like gloves, and all that type of stuff is going to be covered as we move forward. So I just want you to be aware of that. Now, I will end on this one. It's called unqualified persons. So you're either a qualified person or you're an unqualified person. A person who is not a qualified person. Again, if you're working on PV and you have never done PV before, you take a job, I will argue that you're an unqualified person. You don't have the training. You don't have the skills. You don't meet the definition of qualified person. Are you going to do it anyway? Probably are. But you're not qualified. Now, learn about it. Take a class. Do a little study. Train a little bit. Then you can be a qualified person. Okay? But doing something that you're not trained, that you don't have the skills in, you've never done it before, you're not learning from somebody, then you're an unqualified person. And that could be a problem if you ever get injured. Okay. And for owners, remember that you want your people to be qualified. Give them the training they need. Okay. All right. So, there you go. That was dealing in definitions. We didn't cover them all because we didn't have to. A lot of these are regurgitated from the NEC, and we're all familiar with the NEC. There is a lot of definitions in the NEC right here. Article 100 broken down into 3 parts. Check it out. But we didn't have to regurgitate those. But as we move through this series, when we see something that we need to define and kind of put 2 and 2 together, what we'll do is we'll jump back and we'll relate the definition so that you can understand. So hopefully you'll get something out of this series and get a better understanding of electrical safety. Now we're going to move into the actual meat and potatoes of Chapter 1. And we're going to get a better understanding, and we're going to really dive into Article 105 and kind of get this thing going. So I'm excited. We'll see you in the next episode. Until then, stay safe and God bless.